Okay, so welcome everyone to today's class. Okay, so in this class, we are going to continue from where we ended last time. Okay, so last time we were looking at the introduction to statistics. That was part one. So today we'll focus on what? Part two. Okay, so whatever we will learn today, it's a foundation for whatever you will be doing in this course. Okay, so this is a foundation. There are a lot of definitions, there are a lot of theories that you have to know. So start knowing them now. Okay, and then later on, you'll be using them in whatever we'll be doing in this course. Okay, so for today, we have these objectives that we want to look at. Okay, we want to define what raw data is and then talk about types of data. Okay, and then we'll also define a variable. We'll also define a data set, okay? And then we'll categorize these variables, okay, into quantitative variables and qualitative variables. We're also going to look at discrete and continuous variables, okay? And then we're also going to look at cross-sectional data, and then we're also going to look at time series data there. Okay. And then to close it, we are going to look at the sigma notation. Okay. So these are the objectives of this lesson. Okay. So we start from the data there. Okay. So if I explain anything and you don't understand, please feel free to ask. Okay. So from the definition, what is raw data? Okay. So by definition, we can say this raw data is just the data recorded, okay, in the sequence in which they are collected, okay? So you just collect the raw data, okay? You don't have to organize it. You don't have to do anything with it, okay? Just that data that is collected, okay, in the sequence, in the way it is, like without any modifications to the data, okay? That's what we refer to as what? Raw data. Okay, so before it's processed or ranked or before we do anything to this data, okay, that's what we call what? Raw data. Okay, so that's the definition of the raw data. And then we move to talk about the types of data now. Okay, so you can see this flow chart that I've put on the screen. Okay, so that is going to help us understand the types of data that we have. Okay, so data types I've written there. So this data is divided into two. We have what we call as categorical. Okay, this categorical here is also called qualitative. Okay, qualitative. And then we have numerical, which is also called quantitative. Okay, so we know that quantitative, it deals with the numbers. Okay, you can count it. No wonder here you have numerical data. And then this qualitative is just used to group. Okay, so we can also call it as what? Categorical data. Okay, so this categorical data is divided into two. We have one, the nominal data and the ordinal. Okay, so we'll look into details of what these are. And then the numerical data is also divided into two. We have the interval and then the what? The ratio. Okay, so this here is just a flowchart showing the types of data that we have. Of course, we also have the cross-sectional data, and then we have the time series data. Okay, so we are going to talk about all these types of data. Okay, so on my next slide here, I have the nominal data. Okay, so nominal, this nominal here comes from the word name. Okay, so whenever you hear the word nominal, just know that it's data that can be categorized, okay, based on description, okay, based on description. So we can categorize students, okay, based on their programs that they are doing. We can say those are doing maybe medicine, those are doing pharmacy, those are doing physiotherapy, okay, just like that. So this nominal data here cannot be ranked. It does not have a rank, okay? So nominal data refers to the data that can be categorized, okay, but cannot be ranked or measured in a specific order, okay. It is purely descriptive, it just describes, okay, and does not have an inherent numerical value, okay. So this nominal data here just describes. So for example, of a nominal data, it can be the colors of the rainbow, okay. So you can say there's red there, there's orange, there's yellow, there's blue, but okay, your categorization does not show any order, okay? We can't say that red is above blue, no, okay? So we're just mentioning the colors of the rainbow. So there's no order when you talk about what? Nominal data. Another types, it can be, another example, I mean, it can be the types of pets, okay? We can have dogs, some people can have cats, others can have fish, bird, just like that. Okay. So it's just the data that is used to categorize. Okay. Another example, it can be name of countries. Okay. So we can say that one is a Zimbabwean, that one is a Malawian, that one is a Zambian, based on what? Nominal data. Okay. So nominal data has no order. And then, um, okay, even this here is an example. It's just categorizing you. Are you married? Okay. If yes, you will be grouped under those that are married. If not, you'll be grouped under those that are not married. Okay, and then even the languages you speak. So this here is nominal, purely descriptive data. Okay, and then we can talk about ordinal now. So ordinal comes from the word order. Okay, so meaning when we are describing this nominal data, okay, there's order that is involved. Okay, so for example, the level of education that you've attained. Okay, so some they ended at secondary level, which is grade 12. Others they went on and got a diploma. Others they got a degree. Others a master's. Others a PhD. Okay, so in terms of education, we know that the PhD will be on top there, and then you have the master's. Okay, you have the degree. You have the diploma. Okay, you have the grade 12 certificate. Okay, so you can arrange this data in order like that. Okay, no wonder it's called ordinal data. Okay, so this is the definition here that I wrote for you. These notes are there on Drive. Okay, so you can access the notes and you can try to read through. So let me talk about some examples here. Okay, so for example, if we go to the military, okay, there are ranks there. There are those that have lower ranks and there are those who have higher ranks. Okay, so we can go from private to the general. Okay, even equal movie ratings. Okay, so movie ratings, we have those that have lower ratings. We have those that are have higher ratings. Okay, so all that is ordinal data. There's a specific order there. Okay, even the economy class. So there are poor people, rich people. We can organize them in order. Okay, the rich will be at the highest there. So ordinal data is just data that represent categories. Okay, with a specific meaning for what? Order. Okay, so I've explained this, and then here there's example of ordinal data. So depending on your educational background, you can say elementary school, high school, undergraduate, or you're a graduate. So we can arrange the data in that order. Okay, and then the other one is what? Okay, so the previous two, which is the ordinal and the nominal, they are categorical data or quantitative, qualitative data. Okay, and then these ones here, the interval, and then we're also going to talk about the ratio. They are what? Quantitative or numerical data. Okay, so what is interval data? Okay, so interval data is a type of quantitative data that represents measurements with a consistent scale but without a true 0 point. Okay, so what does it mean without a true 0 point? Okay, so it means that quantity, it can be zero, okay, but the zero will not mean it is absent. Okay, so for example, temperature. Okay, so we can say today the temperature is 37 degrees Celsius. Okay, so this will be the temperature. So we have a value there. So this is an example of interval data, for example, the temperature. And then we can also say the temperature today is 0 degrees Celsius. Okay, so this 0 degrees Celsius, it means the temperature is there, but it is 0. Okay, the temperature is there, but it is 0. It doesn't mean that there is no temperature. Okay, I hope you're understanding. If you're not, please ask. The 0 degrees means the temperature is there, but it's 0. Okay, but it doesn't mean that there is no temperature. Okay, so this is what interval data is. Okay, it has a consistent scale, but without a true 0 point. So meaning when you're at 0, it doesn't mean um, the absence of the temperature or the measurement or whatever. Okay, another example is time. We can say the time is 0000. Okay, but does that mean that the time is not there? No, the time is there, but at that specific point it's just what? 0. So important characteristic of the interval data is that it does not have a what? True 0 point. And two good examples are temperature and time. And then in contrast, we're going to look at the ratio data. Okay, so this ratio data here, it has a true 0 point. Okay, so for example, weight. Okay, so if you buy maybe sugar, you say this sugar is 2 kgs. Okay, that sugar will be present there if it is 2 kgs. But if we say there's 0 kg of sugar, it means that sugar does not exist. There is nothing. Okay, so that's the difference with the interval data. The interval will have a 0, but that 0 will not be a true 0 point. But when you look at this ratio data here, it's 0, it's a true 0 point. So when we say 0 kg, it means there's nothing. Okay, even distance, if we say she traveled 0 meters, it means she didn't travel at all. Okay, there's no distance that she covered. Okay, so the ratio data will have a true 0 point, and then the interval will not have a what? A true 0 point. Okay, so that's the difference between the ratio and the interval. And we said this ratio and the interval are under what? Quantitative data or numerical data. Okay, and then I move forward to talk about what a variable is. So if you have a question, feel free to ask, guys. Okay, feel free to ask. Okay, so let's talk about what a variable is. Okay, so I have a definition there on your screen. Okay, so we say a variable is a characteristic understudy, okay, that assumes different values for different elements. Okay, that's a variable. So for example, we can say height of people in class. Okay, height of people in class. So maybe we have students here, maybe we have Mary, we have Paul, we have John. Okay, so maybe Mary is 1.2, Paul is 1.7, and then John is 1.5. Okay, so which one here is the variable? The variable here is the height. Okay, so this height is assuming different values for different what elements. Remember elements, the definition of elements from the previous discussion that we had. Okay, so a member, okay, of here we are going to say name. Okay, so these names here are what? Elements, okay, of this specific what? Data set. So different elements here will assume different values for a specific what? Variable. So this height here is a variable and it has different what? It has different values for different what? Elements. Okay, so a variable is simply a characteristic understudy that assumes different values for different what? Elements. Okay, and then in contrast to a variable, we have a constant. So this constant here is fixed. Okay, it doesn't have different values. It doesn't have, it's just fixed. It's just a constant. Okay, so that's what a variable is. And then this variable can be divided into different types. Okay, so before we talk about that, we can talk about a data set. Okay, so a data set is a collection of observations, okay, on one or more variables. So a data set will be this complete thing here. For example, the one that I'm just from drawing, okay? So let's say this is name, and then we are measuring the height, okay? And then there's Paul here, and then there's John. So we say Paul is 1.7, John is 1.5 meters, okay? So this complete box here is called a what? A data set. It's a collection of observations, okay? It's a collection of observations for one or more variables. So from this data here, okay, we can pick out the observation. So the observation are just these values, okay, that elements are 10. Okay, so these values here are called what? Observations. And then this height here will be called a variable. Okay, and then this name Paul and this name John will be called what? Elements. Okay, so when you combine elements, observations, and a variable, you get what we call as a what? A data set. Okay, so a data set is just a collection of observations on one or more what? Variables. All right, so we move forward to talk about the different types of what? Variables. Okay, so the first one is the quantitative variables. Okay, so under quantitative variables, you are going to talk about two special type of variables. Okay, the first one is the discrete, and then the other one is the continuous. So this discrete here simply means it can be counted. Okay, it's countable. And then the continuous, okay, it's uncountable. Okay, so these are the things that you are going to be using. Okay, you will learn about discrete random variables. Okay, it will be a topic on its own. And then the other main type of variable is what? Qualitative, or we can say categorical variables. Okay, so those are the two types of variables. And then the first type here does it to my subtype, okay, which is discrete there and what? Continuous variables. Okay, so any questions there, guys? Any question? Okay, if there are no questions, I'll continue to define what quantitative variables are. Okay, so we are looking at quantitative variables. So definition, okay. So a variable that can be measured numerically is called a quantitative what? Variable. Okay. And then the data collected on a quantitative variable is called quantitative data. Okay. So a data that can be measured numerically. I mean, a variable that can be measured numerically. It's called the what? A quantitative variable. Okay. So for example, height. You measure height numerically. You say 7.1 maybe meters. Okay, so this here is a number, it's numerical, so it's a quantitative variable. And then quantitative variables and qualitative variables here. Okay, so before I talk about that, okay, all right, so on the quantitative variables, we have these examples here. Okay, so by definition, we say they take on numeric values. Okay, so the number of students in class, that's quantitative. It can be a number of square feet in a house, the population of a city, the age of an individual, the height. All these are quantitative what? Variables. Okay, and then under quantitative, we said we can divide them into discrete. Okay, and then we can also divide it into what? Continuous. So we are first going to talk about the continuous one. Okay, so by definition, a variable whose values are countable, just like I explained. Okay, they are countable. It's called what? A discrete variable. Okay, and then if they are not countable, okay, it's called what? Continuous variable. Okay, and then here we have examples of discrete random variable, something that you can count, okay? The number of cars sold, that's a discrete random variable, okay? The number of houses in a certain block, the number of fish caught, the number of customers who visit a bank, okay? The number of heads obtained in 3 tosses of a coin. Okay, all those are discrete random variables because you can count them. Okay, and then continuous random variables, you can't count it. Okay, it's just between a specific range. Okay, it's just between a specific range. So let's say maybe the distance. Okay, so if we say the distance from school to your home is let me not say the distance, let me say the time. Okay, so let me say the time that you take for you to walk from your home to school is between 0 and 30 minutes. Okay, so this here will be a continuous random variable because you can take any time between 0 and 30. Okay, you can walk, maybe for today you walk in 15 minutes, you reach. Another day, it will be 16.7 seconds, you reach. Another day, you reach after 29.3 seconds, you reach. Okay, so any time that you take between 0 and 30, okay, as long as you are given a range there, you can take any value, okay? That will be called as a continuous random variable. So do I have examples here? Okay, so for example, the height of a person, okay? So the height of a person, or if I come at your school, which is apex, okay, I start measuring the heights of everyone there. I'll get a specific range, okay? Maybe the short person is maybe 1 meters, and then the tallest one maybe is 2 meters, okay? So the rest of you will just be between the 1 meter and the 2. So this height can take any value between 1 and 2. So it's a continuous random variable. And then, for example, the time, as I explained, okay, so here I was saying the time taken to complete an examination. So when you start writing, they say maybe the duration of the exam is 3 hours. Okay, so we see people leaving after 30 minutes, they are gone. Okay, some will leave after 1 hour, some will stay in the exam room until the 3 hours. Okay, so a person can finish writing this exam between 0 to 3 hours, can take any time between this. Okay, so that's a continuous what? Random variable. Okay, and then we can talk about quantitative or categorical variables. Okay, so these are variables that cannot, okay, they cannot assume a numerical value, okay, but can be classified into 2 or more non-numerical what categories. Okay, so let's look at examples here. Okay, so this is the variable, and then on my right here I have qualitative variables. Okay, so for example, or examples of qualitative variables, okay, it can be hair color. Okay, hair color cannot take a numerical value. Okay, you say my hair color is 5 blue. No, okay, you just say it's blue. So that blue there does not have any number associated to it. Okay, so it will be what? Qualitative. So that shows you the quality of that hair. Okay, and then on the other side we have quantitative. I've explained what it is. We have discrete, and then we have what? Continuous there. Okay, so any questions so far on what I've explained before we look at the cross section and the time series data? Okay, silence means no question. Okay, so now let's look at the time series and the cross-sectional data. Okay, so pay attention as I'll be explaining this. Okay, so they're just different. Okay, so they're just different a bit. Okay, so it's like they are opposites of each other. Okay, so cross-sectional data and time series data, they're just opposite. Okay, so you're going to see. Okay, so let's start with cross-sectional data. So this cross-sectional data, okay, it's data that is collected on different elements, okay, at the same point in time or for the same period of time, okay? So cross-sectional data is just the data you collect, okay, on different elements at the same point, okay, or the same period of time. So example is this table that I have here, okay. So this was the collection of the net worth in 202, okay, collection of net worth in 202. So what you notice here is that we have different elements. Okay, we have Bill Gates, we have Warren Buffett, we have Helen Wharton, George Lucas, Ted Turner. Okay, all these are different elements. Okay, and then the period here is the same. So this data was collected what in 2002. So meaning the time is the same, or the time period is the same. Okay. So data that is collected on different elements at the same time is called what? Cross-sectional data. Okay, so you can see the data. This one had 43 billion. Okay, this one had 36 billion. That one 18.832, and then 2.0 there. Okay, so that's the cross-sectional. And then the time series data will just be the opposite. Okay, so remember the cross section, we said different elements and then same time. Okay, so for this time series data, it will be same element, different time. That's the difference. Okay, so cross section time series data, it is the data that is collected on the same element, okay, for the same variable, okay, at different points in time, okay, or for different period of time. That is what we call as time series what? Data. So for example, of the time series data is this here. Okay. So what was the variable here? So the variable is this thing that I'm circling. So this was the price of a 30-second TV commercial during the Super Bowl telecast. Okay, so for example, if we have the World Cup, let me just give example of the World Cup. So the World Cup happens every after 4 years, right? Okay, so let's say we are in 2010. Okay, so in this 2010, we know that during the World Cup, a lot of people will start watching TV. Okay, so what does a company that wants to advertise its products do? Okay, it goes to the TV station which are showing the World Cup, and then maybe it pays them maybe 50 kwacha per advert. Okay, that is in 2010. And then another World Cup comes in 2014. Okay, this company again notices that a lot of people are going to be watching TV, so it means they can easily advertise their products. Okay, they go to the company, and then they go to the TV station, I mean, and then this time maybe they are charged 70 kwacha per advert. Okay. Again, we move. We go to 2018 World Cup. Okay. This company, the same company comes, but the TV station says no. This time, advert 100 kwacha. Okay. So you can see that the data that we are collecting is on the same element. Okay. It was on the same element, but at different what times. The other one was in 2010, 2014, 2018, okay, 2020, is it 2022? The other one 2026, okay? So it will be the same element, but different what? Different time. Okay, the other one will be, so you can see here from this example, the years here are different, okay? But the element is just the Super Bowl, okay? And the prices of these commercials are different depending on the what? The year. Okay, so time series data, here we have same element, different what? Time. And then cross-sectional data, we have different elements, same time. So that's the difference there. Okay, so I hope you've understood this. Okay. And then we can now talk about some sources of data. So we can have internal sources, external sources. We can have surveys and experiment. Okay, so these surveys, they can be form of a Google Sheet. Okay, so I'm sure you've seen a Google Sheet somewhere. Okay, they just send you a Google Sheet and then you put in your information. Okay, so that's the source of data. Okay, so here it doesn't need a lot of explanation. Sources of data, okay, I can see internal, uh, external, and internal here. Okay. Okay, and then it's also important to note that we have some primary data and some secondary data. So this primary data is just the raw data. Okay, you are just collected it. And then after you process it, you do what to it, becomes secondary data. Okay, so that's that about that. And then we can talk about the sigma notation. I'm sure you've seen something like this before. Okay, so in statistics, it will be very important to know what this means. Okay, so this sigma notation simply means summation or addition. Okay, so if, for example, I write the sum, okay, the sum of maybe 1 plus 2 plus 3 plus 4, okay, then I'm just adding. Okay, so this will be equals to whatever I have here. So 1 plus 2 plus 3, this will be 10. Okay, so it means this, whenever you see this symbol, okay, just know that it means what? Summation or addition. So what do you add? You add different elements, okay? You add different, not different elements, but you add different values for a variable, okay? So let's say we have height here as our variable, okay? And then maybe the first person, okay, is called A1. So A1 has the height 1. And then the second person is called A2 and he has the height 2. Okay. The third person is called A3 and he has the height 3. Let's say the fourth person is uh, A4 and it has the height what? 4. So what are we going to do in order to use this sigma notation, okay, to find the sum of those heights? We can just write the sum of those heights as summation, okay, of AI, okay, where this I represents these two numbers here, 1, 2, 3, and 4, okay? So we are going to say I, down here, you're going to write I starts from 1, and then it ends on what? 4. So this here expression like this, you're going to see it a lot in statistics. So this simply meaning we are just adding the values of this variable from 1 all the way up to what? 4. Okay, that's what it means there. So it means summation of this AI from 1 to 4 will just be, you put your A1, A2, A3, A3, A4 there. Okay, you are going to get what? 10 as your answer. So now let's look at an example. So here again, I was explaining what it means. Okay, so you have the lower limit here where you're starting from, and then there you have the upper limit where you are ending. Okay, and then this symbol here simply means summation or sigma, and then here you have the formula for the terms, okay, that are in that sequence or that were collected for that what variable. Okay, so this is the same here. So for example here, okay, so example 1, they're saying annual salaries in thousands of dollars of poor workers are 75, 42, 125, and 61. Find the summation of X, okay? So we'll say let X be the annual salaries in what? This thousand. So summation of X will just be equals to 75 plus 42 plus 125 plus what? 61. Okay. And then what about summation of X squared? It means whatever we are going to get on the summation of X, we square it. Okay. So first you do this and then the answer you square it. And then now notice this one that we have on C. We have summation of X squared. So there summation of X squared, okay, you have to square each term. So it will be 75 squared plus 42 squared plus 125 squared plus what? 61 squared. So just punch this into your calculator to find the answer. So notice the difference between this one on C and then this one on what? B. Okay, so this one on B, we're first finding the summation of X and then we square it. And then this one C, we are squaring the individual salaries in this given question here. Okay, so next question. So these were the answers to those questions. Okay, so you can see summation of x and then square. You just get the answer that you got here and then you square it. But for this one, you square each individual like that and then you add. Okay, so that's what the summation symbol means. And then we have this exercise here. So screenshot this, okay? And then you try to find it. Okay, screenshot this and then you try to solve it. Okay, so the first one is summation of m. So you're just going to add the values of m here. The second one is a summation of f squared. So you are squaring this plus squared of this plus squared of this plus squared of this. Then the third one is the summation of mf. So you are going to be multiplying 12 multiplied by 5 plus 15 multiplied by 9 plus 20 multiplied by 10 plus 30 multiplied by 16. Okay, and then the other one there down here we have m squared multiplied by f. So it will be 12 squared multiplied by 5, okay, and then plus 15 squared multiplied by 9, just like that. Okay, so make sure you try out this question here. I think it has solutions here, so I'm going to bypass it fast like that. Okay, and then at the end here, we've reached some example questions based on whatever we've discussed there. Okay, so example questions, we have the ones based on the definitions. Okay, so describe two terms of statistics. This we did in the previous. Okay, so we know that statistics can be defined as a numerical quantity or what? A field. So it's very important to know these two definitions here. Then explain the types of statistics. We did that. What a population is, what a sample, what a random sample. All this we did in the first what? In the first lesson. Okay, so there's really nothing that I can do to make you know this. You just have to study and then master the definitions. Okay, when they come, you just answer them. Okay, so I think some questions here we did. Okay, so here now we have an addition of questions. Okay, you can see this one here, they're saying define the following in statistics. So we have cross-sectional data. Okay, so we said this here, you calculate it. It's the data collected on what? We said different elements and then same time. Okay, what is ordinal data? Okay, this ordinal data is a descriptive data, or you can say qualitative. Okay, that shows hierarchy, okay, or order. All right, so there are lots of questions here, and these notes are on Drive, so you can pass through. Okay, I shared the link of the Drive in the group. Okay, but now let's try to answer this question here. Okay, so answer together. So they're saying the table below gives the number of students who passed in schools A, B, C, D, F, and F there in the year 2022. Okay, so we have the name of the school, number of students, okay, and the schools here. So now the question comes. So these questions I'm asking you guys. So I expect responses. Okay, so the first question is, what are the variables in this data? What are the variables in this data? Anyone? This is the data here. Okay, so what are the variables? Come on, guys, what are the variables from this table? Hello? Okay, seems like no one wants to answer. Okay, so the variables we said is the thing that attains different what? Values. So this here, the number of students passed is the variable in this case. Okay, and then how many observations are in this data set? You just count 1, 2, 3, 4, 5, 6. So we have 6 observations. And then How many elements? Okay, so the elements are always equal to the number of observations. So 1, 2, 3, 4, 5, 6. So these here, the name of the schools are what? 6. Those are elements there. Okay, so these questions, such type will come for you guys. So better know them. Right, and then we have definitions here. So master the definition that I gave you. And then here they are asking which one is quantitative, which one is qualitative. We said quantitative, we have a numerical value attached. Then the qualitative is all about the what? Categorizing or the quality. Okay. So the name of the person is qualitative. Colors of the house, qualitative. Job title, qualitative. Time to move from home to school, quantitative, because there's a number involved. The number of students enrolled in pre-med, quantitative. Okay, so such questions are waiting for you. So better be studying, guys. Okay, so all these are questions here. You can try them out. They are all on the what? On the drive. Okay. All right, so that's all for this lesson. Unless you guys have some questions for me, you are free to ask. So any questions?
Hello. Thank you so much. Thank you.
All right. All right. Thank you so much and have a blessed night.